This is an Arduino UNO, and if you have ever held it, tasted it, or even smelled it, then you have most definitely come across its millis function. The millis function is a timer-based function in an Arduino that provides the elapsed time in milliseconds from when the board was powered on or last reset. Now, the Arduino UNO has 3 hardware timers built into it: timer 0, timer 1, and timer 2. Essentially, what these timers do is they count clock cycles. The millis function makes use of timer 0, keeping track of the elapsed time in milliseconds and returning that value to our code. Enough with the theory. Now let's jump into some code. So I'm not going to be opening up the Arduino IDE for this. Instead, I'm going to be using WorkWii. Now WorkWii is an online electronic simulator that allows us to simulate Arduino projects directly in the browser. And by the way, this video is not sponsored by WorkWii. Okay, so open up a new project. We have our setup and loop functions here, standard starting point. Now the millis function is a built-in Arduino function, and to access it, all we need to do is create a variable of type unsigned long, and we are going to initialize that variable to the millis function. So let's create a variable. We'll call it current time, and we'll initialize it to the millis function. Now this function is going to return the current elapsed time in milliseconds from when the board was powered on or last reset. In my own situation, when I start the simulation. Now to actually view this value, we are going to print it out to the serial monitor, and for that we are going to quickly start up serial communication. Now let's print out our time. Okay, now when I run this program, it should print out current time, then beside it the current elapsed time in milliseconds.
A few moments later.
Alright, so as you can see, we have current time, then the current elapsed time in milliseconds is being printed out to the serial monitor. Okay, with that done, let's see how we can make an LED blink using the millis function. So for this, we're going to need an LED, a resistor, let's put it at 220 ohm, and a breadboard, which is optional but recommended. Let's take the breadboard mini. Now we're going to connect the LED to the Arduino. This is the cathode. Let me flip it. Okay, so the anode goes to a digital pin. I'll use digital pin 3. And then we're going to connect the cathode to ground through the resistor. And boom, hardware connection done. Next, we are going to the code and we are going to configure the LED. So first off, let's create a variable for the pin. Let's say LED pin. And inside setup, we're going to use pin mode to set our pin as an output pin. Okay, now we have our LED being configured. Now let's say we want the LED to blink every 5 seconds and we want it to stay on for 2 seconds. So we are moving out to a loop function. So first we are going to create a variable to hold the current elapsed time. Let's call it current time. And we are going to initialize it to millis. So now this will hold the current elapsed time as we saw previously. Next, we are going to create another variable called previous time, but this variable is going to be a global variable. So we create it outside of the loop function and we initialize this one to 0. Now what this variable is going to do for us is it's going to keep track of when the timing cycle starts. So for the first timing cycle, it's going to start at 0 milliseconds. The second timing cycle will start at 7,000 milliseconds. After 7,000 milliseconds, because from 0 to 5 LED is off, then from 5 to 7 the LED is on, and that will complete one on and off cycle. Now back to the loop function. For the first 5 seconds we want the LED to be off. So if current time minus previous time, these are the duration, if it's less than 5,000 milliseconds, which is 5 seconds, we want the LED to be off. So we digital right now. Once the duration reaches 5 seconds, that's 5,000 milliseconds, we want that the LED should turn on till about 7,000 milliseconds, and this gives us our 2-second on period. So we're going to go after 7,000 milliseconds. Neither of these conditions will be true, because after 7,000 milliseconds we have 8,000, 9,000, and so these conditions will no longer be true, making this behavior to happen only once. So it will be off for the first 5 seconds, then after 5 seconds, from 5 seconds to 7 seconds, it's going to turn on. In order to fix this and make sure that the behavior goes on forever, we are simply just going to initialize previous time to current time. This resets the cycle. This like starts a new cycle. So we're going to do previous time equals current time. Immediately as our current time reaches 7,000 milliseconds, all the conditions above the else no longer hold. So previous time gets equated to 7,000 milliseconds and the duration becomes now 0, because 7,000 minus 7,000. Let's start the simulation and see. 5 blink, 7 off, and there you have it guys. That's how you can blink an LED using the millis function.